Hey everybody. Let me tilt that down a little bit. There we go. My wife gave me a haircut the other day, and I don't know how it turned out. Kind of long, still on top, but whatever. Do what you can do, right? All right. So this is just a video over section 11.6, day 2. Talked about a little bit in the first video, splitting it up into 2 sections because the first section we were focused on using factor trees. Okay. Now, factor trees are good to use, but some of you guys may have noticed that you do a tree, and then 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 it's another tree, and another tree, and another tree, and another tree, and it can get kind of like extensive. Okay, so I'm going to teach you a little bit more, how do we see, eloquent way to do it. Again, guided notes are probably in the link above this video or below the video. But make sure you print them out if you need them. Some of you work well with guided notes, so make sure you do that. Okay, let me get my face out of the way. All right, so this is day 2, radical expressions, day 2. All right, now, one of the properties that we've learned, that we may or may not have learned, I'm not sure if we've done this. I think the reason I say that is because I think it shows up earlier in the chapter 11, which we've kind of bypassed a little bit. So one of the things that we know is that if I have the square root of a product, there's this property that says if I have the square root of a product, okay, the square root of 2 things that are multiplied together, A and B, then I can separate that square root to the square root of the first thing times the square root of the second thing. I can basically break this square root apart and make it both square root of A times the square root of B, okay? Now, why does that help us? Well, that helps us because, let me get that out of there. That helps us because if I have something like this, the square root of 12, well, I can actually separate this out, and I'm going to strategically separate it out. I'm going to make 12 as 2 different factors. The square root of 12 is really just 4 times 3. Now, why did I do this? Why did I say 2 times 6? Or why did I say 12 times 1 or something like that? Well, 4 is a really special number. It's a perfect square. So if I can take this number, the radicand, and factor it into, and now when I say factor, don't get worried or anything. If I can break this into a perfect square in another number, like 4 times 3, what I can do here is I can say that this is the square root of 4 times the square root of 3. Now, the reason it's nice that this is a perfect square is because that will come out as a whole number. The square root of 2 square root of 3. Square root of 4 turns into 2, okay? See, I could, if I really wanted to think about it like this, and that's my answer, by the way. If I really wanted to think about it like this, I could say the square root of 2 times 6, right, if I really wanted to, but does that really help me at all? No, the square root of 2 is a decimal, 1.4 something. The square root of 6 is, 2 point something, right? There's not perfect squares, so they don't reduce nicely, But this is a perfect square, and it will reduce nicely. Square root of 4 is. So now, the other method of doing that is the factor tree method. If I break that down, 2 and 6, and 2 and 3, and I buddy that up, 2 times 2 times 3, okay, buddies, 2 radical 3. Do you see how we get the exact same answer? So this is just a different method of doing these things, okay? Now, on the homework tonight, on the homework for the next day, the page 809, I want you to be using this method. I don't want you to be using the factor tree method, okay? All right. Okay, so the square root of 300. Now, what I have to do here is I have to start thinking about what are perfect squares. Like if I take 300 and I divide it by, well, what are perfect squares? 4? Yes, but is there a bigger one? Maybe 9? Maybe 16? Nope. Maybe 25? Ooh, is there a bigger one? Can you see it? Yes. Okay, so what I can do here is take the biggest perfect square I can out. So that means I've got the square root of 100 times the square root of 3, and the square root of 100 is just 10. Okay. Now, I think this problem demonstrates exactly why this method is a little bit easier than the factor tree method, because look at this. 2 and 150, 2 and 75, 3 times 25, 5 5 times 5. Okay, so that's 2 times 2 times 3 times 5 times 5. Buddies, 10, because that's 2 and the 5, right? Make the 10, and then the 3 staying in. Same answer, right? Yeah, that's a lot less steps doing it that way, right? I hope you would agree with that. The only problem is you have to look for the biggest perfect square that's a factor. Okay. All right, let's take a look here. Square root of 80. Okay. Now, I would go for big, What's, oops, get out of there. So I want 80. What's a big perfect square? Well, obviously, if I go up through the list, what's close to 80? 81. I can't divide 80 by 81. Okay, so that's 9. 8, 64. Obviously, that's not going to work out nicely. 7 is 49. Nope. 6 is 36. Nope. 5 is 25. Maybe. Nope. 16. Yes. So this is a square root of 16 times 5, right? So that means it's the square root of 16 times the square root of 5, which is 4 radical 5. Now, you may be thinking to yourself, Mr. Laverick, why do I need to write this step in there? Can't I just break this apart here and go straight to my answer? Of course you can. Yeah, that's totally fine, okay? It's no big deal. Now, some of you guys are going to like this method because it's a little bit easier, if you know your perfect squares, if you know your perfect squares up to, I don't know, 10 at least, then you're going to be able to recognize those and do that math quickly and say like, okay, what is it? Is it divisible by 9? Is it divisible by 16? Is it divisible by 25? Divisible by, and all those pretty quickly in your head. Okay, so let's take a look here when I start simplifying fractions. Remember that I can break this apart and say the square root of 5 divided by the square root of 4. Now, why does that help me? Because this turns into the square root of 5 over just 2. Is that simplified? Yes. It is simplified because there is no square root in a denominator, right? It can be in the numerator, just not in the denominator. And then 5 does not reduce down. If I think about, is there any perfect squares that divide 5? 4? No. 1? Yeah, but obviously if anything divides by 1. Okay. Let's take a look here. Now, first thing you should do is to see if you could reduce down the fraction. Can I reduce down this fraction? Yes. I can divide both top and bottom by 3, which gives me the square root of 4 divided by the square root of 9. 2/3. Okay. Take a look at this one. Okay, remember, break that apart. Okay, square root of 36 is 6. Now, some of you may have been catching on to this in the last video, but if I was truly to do the buddy system here, I'd get an x squared. But some of you are like, well, Mr. Levin, aren't you just dividing that power by 2? Yes, and that's the shortcut I'm going to allow you to make right now. If this is an even number, all you have to do is divide it by 2. Okay, you divide it by 2 because you're pairing it up anyway. So you're finding how many equal groups of 2 do I have? I have 2 equal groups, that's division. Right? Finding equal groups of is division. So you can divide. Now, if it's an odd number, like if I had an x to the 5th or something like that, I could say, okay, divided by 2. Well, I've got 2.5, right? I've got 2 with 1 left over. 2 with 1 left over, right? So it's up to you. If you want to think about it using that listing it out method, that's fine too. 2 coming out, 1 left over. Doesn't matter. Okay. Let's try another problem. Okay, so this is, now reduce down the fraction if we need to. Look, I can reduce that down. The m's can reduce down, leave me with an m squared over 9, which means I can take the square root of m squared divided by the square root of 9 to get an m over 3. There's my answer there. 108 divided by 25. Now, the only factors of 25 are 5 and 5, so I don't think this reduces down very nicely. Or, I'm sorry, the fraction doesn't reduce down at all. Okay, so I'm going to get the square root of 108 divided with the square root of 25. Now, we would say the square root of 108 over 5. Square root of 25 is 5. But does that 108 reduce down? Let's check and see. Okay, I said no factor trees, but let's see. Does 108 divide by, let's check. What's a perfect square? It's not going to divide by 100, not going to divide by 81. 6 times 6 is 60, or 8 times 8 is 64. No. 49. Yeah, it's 2.2 something. So 108 divided by 36. Bingo. There it is. Okay. So this turns, oops, that's an eraser. This turns into, well, I'll just do it over here. The square root of 36 times 3. Or the square root of 36 times the square root of 3. Or 6 radical 3 over 5. There's my answer there. It's kind of a tricky one. Let's take a look at this one. So reduce it down. This is 9x to the third over the square root of 16. Okay, so this is, reduce this down. The bottom turns into 4, right? I hope we see that already. Square root of 16 just turns into 4. The top, okay, so this is a 3. Well, if I just work with this, right? That gives me 9 times 9 is 3. And then I've got 3 x's, right? So that's an x coming out and an x staying in, because there would be 3 x's total. Buddy up 1, that's the one that comes out. This is the one that stays in. So this turns into 3x, radical 3, radical x, all over 4. There's my answer there. Okay, let's keep it moving. Last couple problems here. Okay, does this reduce down at all? Well, 49 only divides by 7 and 7, and 20 doesn't divide by 7, so maybe I can reduce down 20 a little bit. I notice 49 is a particular number. It's a perfect square. Square root of 49 is 7. But the square root of 20 turns into, okay, let's do our new method here. 20, does that divide by 16? Nope. Does it divide by 3 times 3 is 9? Nope. Does it divide by 4? Yes. Okay, so this turns into the square root of 4 times 5. So the square root of 4 is 2. There's my answer there. Okay. Oops, let's get the screen shade out of the way. There we go. Okay, now does this reduce at all? Nope. So I'm going to have the square root of z to the 5th divided by the square root of 25y squared. Okay, so the bottom turns into 5y, right? Square root of 25 is 5, square root of y squared is y. Now, this z to the 5th, okay, divided by 2. Let's go that method. Divided by 2, I get 2 with 1 left over. 2 coming out, 1 left over on the inside. 5 divided by 2 is 2 with a remainder of 1, 2.5. Okay. So 2 coming out, 1 staying in. I could write the exponent of 1 there, but I don't really need to. Okay. And then the last example like this. Okay, no common factors here. I can't reduce it down. So this turns into the square root of p to the 6th divided by the square root of q to the 10th. Ah, even powers. Awesome. Divided by 2. P to the 3rd, q to the 5th. Here's my answer. All right. Last problem is a word problem. All right. 2 archaeologists leave from the same campsite. One travels 10 miles due north, and the other travels 6 miles due west. How far apart are the archaeologists? Give the answer as a radical expression in simplest form, then estimate the distance to the nearest tenth of a mile. So here's the diagram that I've gotten. Now, what can we do here to solve for the hypotenuse of the right triangle? We learned it in middle school. Yes, Pythagorean theorem. 6 squared plus 10 squared is equal to, we'll call it c. Call this unknown length c. 36 plus 100 is 136. Now, how do I solve for this? Square root of 136, and that's my c value. Okay, so now it says, give the answer as a radical expression in simplest form. Now, does that divide out? Now, when it's a weird number like this, I like to do the factor tree method, so let's do that. Let's find 136. 136 divided by 2 gives me 68. 2 and 68. 2 and 34. I think that's 2 and 17. Let me check on that, though. Divide by 2, divide by 2, yeah. And I think 17 is prime. Yeah, 17 is prime. So that will turn into square root of 2 times 2 times 2 times 17, which is, buddies here, 2 times 34. So that's what it is in radical form. Now, when I actually figure it out, when I take the square root of 136, this is a weird calculator. I got 136 and the square root, 11.7, I think. Did I say round to the nearest tenth? Yeah, 11.7 miles. Okay. Again, I hope everybody's having a good day. I'll see you all later.